Today we're going to talk about representing relations. The argument that I'm going to put forward to you is going to be fairly abstract and really structured. But it's in this structure that we build a lot of the arguments in math. Structure, although at first might be confusing, it'll enable us to tackle more complicated arguments with greater precision, and our arguments will be more concise as well. So a really important item in math is something called a set. A set is a collection of distinct objects or elements. So a set is just a collection of objects or elements. An element of a set is an object in the set. One way to write a set is to list the elements inside. So here, these brackets are called set brackets or braces, if you will. I like to call them set brackets because they imply a set. For example, we can write the set of natural numbers from 1 to 5. Well, all the numbers from 1 to 5 that are natural would be 1, 2, 3, 4, 5. So here is my set. It's the collection, and any one of these numbers I can refer to as an element of that set. A relation between two sets is a collection of ordered pairs containing one object from each set. If an object X is in the first set, then the object Y is in the second set. The objects are said to be related if the ordered pair XY is a relation. So we're going to have generally one variable that will have a first set, and we can call that the element of the first set, and a number or another element of the second set. And there will be an association between these two. So if I was talking about fruit and color, you could say, well, an apple, that would be an element in the first set, may have the color red. Now the association would be may have the color, and the element in the second set would be red. So if this is a set of ordered pairs, we can have a relationship that here is a set of ordered pairs, right? Normally ordered pairs, we have X, Y, but here we're going to define it as different. We're going to have it fruit and color. Apple red, that would be one ordered pair. Apple green, that would be another ordered pair. Blueberry blue, cherry red, huckleberry blue. And all of them together can be described as our set. Now here are some other ways to represent a relation. We can have a table, one in which we make a table. Now you guys are probably thinking XY table, but here I'm going to label my fruit. And on the right-hand side, I'm going to have the color associated with that fruit. Now what we see is apple can actually have two colors. So this is a table, and tables are really useful later on, and you probably have experience, in particular, an XY table. We can also make a diagram. So we have two ovals representing each set. So over here, I guess I would have fruit, and over here, I could have color. So the first set represents the fruit, second set represents the color, and what we can see is that there's a relationship that exists between fruit and the color. The order of words in an ordered pair in columns in the ovals, the order of words in the ordered pairs, the column in the table, the ovals in the arrow diagram is important. It makes sense to say an apple may have the color red, but it doesn't make sense to say red may have the color apple. So with a relation, there is a directionality associated with it.